have HDMI
Yes.
port? All right, so as the presenter is getting ready, so let me get my note out. So the next presenter is going to present the paper that is titled RydeeNLP, right?
Yes.
Personalized Japanese learning through NLP-powered proficiency adaptation. So, I give my message.
Yusuke, yes, that's correct.
Yusuke Satani.
Can I sign up? Yeah. Hello everyone, thank you for being here. My name is Yusuke Satani. I'm from Darbestown College, Pennsylvania. So my project is called RydeeNLP, a personalized Japanese learning through NLP powered proficiency adaptation. So here is today's outline. Now we will go over the in the introduction, we will go over the motivation of this work, and in the related works, we will go over the research done before. In the contribution, I will explain what things we did in our work. In the design section, we will go over the flow of the project, and in the result, we will go over the outcomes, and in the future works, we're going to talk about the improvement we can make in the future. So I would like to start my presentation with a question. How many people are studied Japanese before? Okay, zero. Japanese seems not popular here, but actually the Japanese learning situation changed a lot. So as you can see, that over 17 million people study Japanese now. According to the report from Duolingo, Japanese is the 5th most popular language, which is great. And also my college has big Japanese major. However, I noticed there are students studying Japanese having a rough time to study. And I also noticed some programs about the learning Japanese. So what are the programs? First one is about the vocabulary study. So there is no studying tool that provides you the personalized vocabulary study. For example, the Duolingo is really popular to learn new words. However, the Duolingo forces users to follow the path they made, so it's not personalized. Next program is about the practice reading. So there is no supporting system to provide you the translation or the sentences that corresponding to your vocabulary level in Japanese. So I have decided to build a Japanese supporting system because I'm from Japan and I know Japanese very well. So here's an overview of my project. This project composed from mainly two parts. First one is about personalized lexical translation. Next one is browser extension and desktop app. So what is a lexical translation? This is a technique to replace difficult words into simpler ones. So and the original meaning does not change. So what is a great point of lexical simplification? Translation models focus on the correctness from the original sentence. That's why sometimes it contains difficult words to understand for Japanese learners, because Japanese learners tend to have the limited vocabulary. So this is helpful. And each component have their own program. The first program about lexical translation is about training dataset. We don't have the enough size of the Japanese translation dataset. Next program is simplification model itself. So there is no fine-tuned language model trained with big dataset. And another program about UI and application is that there is no all-in-one personalized learning tool. So this is not helpful to support Japanese learners. So here is the related works. First two program works about building word swapping model. This is part of the translation model, but this is a little bit old and I won't touch it here. Next paper is about making two models. Fine-tuning model is new and more flexible and useful. However, the dataset used is very limited. So here is my work. It has the big dataset and trained two translation models, and this is the first one support learning system. So I will. This is a contribution we made for training dataset. We expanded the range of the words by incorporating new criteria for school level. This school level has 3 types of category: elementary, middle, high. And next contribution is building model. We built single fine-tuning model that can generate translation corresponding to the user's vocabulary. And contribution for the UI and application is we built a learning tool which connects the personalized reading practice and vocabulary study, because they are tend to separate it, so we try to combine it. So here's the design section. Okay, so first is a dataset. We use 2 types of dataset. So first dataset we used is the textbook dataset, which comes from the National Institute of Linguistics in Japan. And next dataset is we built. We made the web script dataset. However, this dataset is not enough. I mean that the dataset is very limited. So we have decided to build vocabulary level classifier. These classifiers are trained on the textbook dataset, and these are the features of the classifier model. This classifier model is applied to the Japanese big corpora. By doing this, we can easily expand the vocabulary with dataset. So here is our vocabulary difficulty dictionary. The great point of this dictionary is that it has information of the difficulty. For example, this word is elementary school level word, and this word is high school level word, etc. So let's move the lexical translation model. So we try and fine-tune model as I mentioned before. First, we tokenize the words and evaluate each word level using dictionary we made. Then we expand the English source side sentence. What we did here is adding the tag at the beginning of the English input. L2 means a high school level, L1 means middle school, L1 means elementary school. Then we fine-tune the model. What we're trying to do here is to make the model learn the relationship between the vocabulary and school level. And here is the demo. So first, the users choose the school level they want to translate, then put the English sentence, then click the generate button. Our trained model is exported to the backend of the web extension. Then it will generate the translations corresponding to the school level user chose. Then after that, the translation is tokenized into the single words, as in the blue. Then you can click any words you are interested in. For example, that if you don't know this word and you want to know the meaning of this word, you just need to click. Then it will show you the English definition. Then you just need to the button at the bottom. It's a generate flashcard deck. Then the flashcard deck file is automatically made, so you don't need to do anything. Just click the button. Then you can import the flashcard app, and the word you chose appeared here. Then you can use the flashcard app, and you can keep learning new words. The great point of this learning system is very efficient. You don't need to make flashcard by yourself. You just need to keep reading and click the new word or click the word you want to learn and use the flashcards app. So here's the result. We built the 3 machine learning model and 4 deep learning model. When it comes to the accuracy, random forest scored the highest, and MLP model scored the second highest. However, when it comes to the level classification, MLP scored the best for the balancing classification. So MLP were chosen. When it comes to the dictionary, our dictionary contains almost 149 keywords, which is huge, which is great. And here's the result, blue score. Blue score is a score to measure the quality of the translation. And this score is score decent compared to the original model. And here's the future works. First, we need to improve the accuracy of the variable classifier because 63%, which is not what we want, so we need to improve. Also, that we need to improve the translation model so that we can generate better translation. Also, my school level only have 3, which is not enough, so we can add some so that we can generate translations corresponding to the user's vocabulary level more. And here's my GitHub repository link. Please feel free to check it. Yeah, thank you very much. That's everything.
Question?
I have one question. Can you
Yep.
go to the previous slide?
Mhm.
So you said for future work, you plan to work on improving the accuracy. Do you have any initial idea of what you will use to do that? What algorithm?
Sure. We use one of the features of the web classifier is vector, like word embedding vector. So, but that word embedding vector is from the newspaper website, so it's not like checked well. So if we work on the word embedding vector, I think we can improve the accuracy more.
I have a question on the comment. I know you didn't do like a user study to gauge, but as someone who's bilingual, how do you see the translations for the different grade levels?
I think it's really helpful for me to enter the college. I practice reading a lot. For example, I read some sentences from SAT test, but the vocabulary was too much. So if I have to do something like this, I want to generate easier translation and get experience to read like difficult topic. Then I can go back to original one which contains difficult word. Then I can gradually get experience in the difficult sentences.
I guess you mentioned that your school has a large Japanese program. I think a user study would be appropriate just to get some feedback from others. That would be helpful.
Thank you very
Nice
much.
work overall. Thank you.
Any other questions?
There's one more.
Yes.
Oh, just more of a request, can you go to your last slide? I'm interested to see if I can get over your
Yes.
I just want to comment on his work as I'm his advisor. So Yusuke is graduated. If you have any positions or grad school openings, he's open to work.
Yeah, I'm really open to both, so please let me know if there is any open job or any like references. I really appreciate to that.
Thank you very much. Thank you.